So what I want to talk about, though, is a lot of the new features that are coming in the Helium release of Salt. This is the biggest release we've ever done. It's taken much longer than any other release we've ever done. It's gone through substantially more testing and implementation. It's actually in production right now at companies like Salesforce and LinkedIn. So it's very thoroughly tested and ready to go. It has a lot of new and very exciting pieces of functionality. And so I'm going to walk through and talk about some of the things that we've got that are coming that's new in this release. Given our audience, I'll highlight a lot of these features wrapped around fundamentally the more fundamental aspects of Salt, what it is and what it does. Okay. So, one of the things, where's my mouse? There it is. I'm very much a nerd. I am giving you a presentation out of a console running Vim. So
zoom in anymore, Tom?
So this is called a wipe. Okay, now for those of you familiar with Salt, Salt is an asynchronous command and control system at its core. And that remote execution engine is fundamentally built on top of a technology called ZeroMQ. Now, we have had a lot of requests to change out that underlying transport mechanism. Not that there's necessarily anything wrong with ZeroMQ, but we discovered that there's ways to make Salt scale better. Even though it already scales very well, there's ways to make it faster, even though it's already very fast. And there's ways to also make it easier and more convenient depending on the scenario in which you're running your platform. One of the big things about Salt and one of the big things about how it is developed is that we have made Salt to be an automation system which solves your problems regardless of what they are in deploying an infrastructure. Instead of trying to say, here is the doctrine or the way that you should deploy your infrastructure, follow us in step. We say, let's help you solve your problems. So, the new release of Salt is coming with a new transport that is being released in an experimental, as an experimental transport. It's called RAET, the Reliable Asynchronous Event Transport. It is an asynchronous, encrypted, secure messaging transport, which is truly asynchronous all the way down. There are many asynchronous queuing and transport systems out there, but they're all built on top of synchronous technology. They're just an asynchronous abstraction. Whereas RAET is truly asynchronous all the way down to the bottom. It's a very, very exciting socket and network library. Now, RAET itself, as a network library, is available open source to use independent of Salt. It comes built in with Dan Bernstein's libsodium encryption, or NaCl encryption, which is generally considered in extremely high regard today, especially considering what's going on in the cryptographic community right now. It has been going on this past year. It's also extremely fast and extremely easy to build highly secure and reliably secure systems with it. So we're very, very excited about the RAET system. It's going to allow Salt to scale more. It's going to allow Salt to be faster. It's going to allow us to build a lot more capabilities around clustering, masters, and shared data across an infrastructure, things of this nature. But so this is the alpha release of Salt on top of the new RAET technology. We've got a tutorial right here that walks through exactly how to set it up with Salt, which is extremely brain dead easy to do. You just have to change one config value to say, oh, we use RAET now instead of ZeroMQ, and you're off and going. Okay, so this has been a huge development effort, most of which has been done by Sam right there. He's a genius. And yeah, we're very, very excited about it. So that's really the headline feature of the new release. Okay. The next big thing for this new release has been a complete revamp and overhaul of the Salt SSH system. Now, using Salt with ZeroMQ or with RAET requires that you have an agent on all of the systems you're communicating with. Now, obviously we're obsessed about the transport, making it fast, otherwise we wouldn't have gone through the trouble of making another one that's fast and scalable. But we've had a number of people who've come back and wanted to engage in what they call an agentless approach, even though you're just using SSH as an agent. So that is why we've developed Salt SSH. Now, Salt SSH was originally developed last year. We put it out in the wild, got a lot of feedback about how people wanted to use it. And it was admittedly developed initially to separate the transport systems inside of Salt so that we could develop RAET. But we got a lot of traction, a lot of excitement, a lot of interest in Salt SSH. So we decided to put a lot more effort into it. So we've got a complete revamp. It is faster, much more usable, much more featureful. The things that people have been asking for inside of Salt SSH are all there now. So we've got a lot of really exciting things. So Salt SSH no longer has any binary dependencies. It has no dependencies which are not Python. So you can pip install Salt SSH on your laptop, write some states, do some remote execution immediately right after the install. So actually, I was going to do a quick little demo here. I've got on this system, if I'm going to run this command, and it doesn't so much as need to look at a config file with Salt SSH. I'm able to say I'm using the scan roster, which says I'm going to scan a network to find out where the SSH hosts are that I can connect to, and then execute a Salt remote execution command, in this case just a test.ping. Now if any of you recognize that IP address range, that's local KVM machines on my laptop. And so it's discovered, yep, we've got a machine with an open SSH connection at this address. Do you want to put a password in and connect to it and deploy a key so that we can keep working with it? I'm able to put the password in, and there we go. And so again, seamlessly, I'm able to go out and start doing anything that I want to do with Salt's vast library of execution modules. Now that test.ping, for those of you who are new to Salt, that is a reference to one of the functions inside of Salt's execution library. Salt comes with this vast library, which is always growing. It's pretty ridiculously large. There's over 250 modules in it right now. And these modules range from everything from installing packages using the underlying package managers. It normalizes the package interface, so we can just say pkg.list packages. And that's going to go out and list the packages regardless of what the underlying operating system is that I'm working with. Okay? Yeah. And then everything that it returns is returned in a JSON serializable data structure, which means that all of the return information needs no parsing from every routine that you execute. So that we can do things like, and this is Salt SSH, so it's incredibly slow, embarrassingly slow, compared to like normal Salt. Okay, but I'll just do a couple of these and then we'll move on back. But so I ran network.interfaces there, and it returned all of the information about all of the network devices on those systems. And it's in a completely, again, normalized format. So if you've got Windows machines and you run that, it's going to give you the same data structure with the same network information that it gives you for a Linux machine or a BSD machine or a Mac machine. Okay. So, a couple other things with Salt SSH. Pure Python, I mentioned that. The next thing is that Salt SSH can now work with our file system backends. File system backends in Salt is very, very slick. It allows you to go into your configuration and define that all of your Salt formulas, which are used in the configuration management system, are going to be pulled directly from, say, a Git repository, or from Amazon S3, or from a Mercurial repository, or if you work at a company that's existed for a very long time, an SVN repository. I got a few chuckles. Yeah, we don't do CVS. Nobody wants it. If somebody contributes it, we'll probably accept it. Actually, I don't want to maintain that. Anyway, the fileserver backend is really cool, especially now that it's in Salt SSH, but it allows you to commit code to a Git repository and then instantly have anybody who has access to that repository use Salt to push that code out, which makes working in teams extremely easy to do. Okay. I'll skip a couple there, which are kind of deep, more pure Python stuff. Okay. So long story short, if I was very slow about all these, I'd have you in here for about 4 hours. Other people want to say things. I have to be nice. But long story short, Salt SSH is really slick now. I should also mention we added a system into Salt SSH so that it can detect where all of your Salt installed and connected minions are. This is a wonderful little fallback so that you can say, hey, maybe I ran a Salt command that destroyed all my Salt minions. Because Salt's powerful. We've had the same problem in the reverse, where someone says, well, I did something that destroyed all my SSH connections, and thankfully I have Salt installed. But so, you saw me type in that -- roster scan. You can now just say -- roster cache, and it will look in the Salt master's caches, if you're running Salt SSH from a master, and then allows you to directly communicate with all of your Salt minions over SSH without redefining where any of them are. So it makes it very, very convenient to say, oh, we've got an SSH fallback into all of our systems if something goes wrong with Salt. Okay, so a lot of people like that redundancy. All right, the next thing that this release has done is that we have added substantially more to the configuration management system. Now the cool thing here is that we're not telling everybody that they have to rewrite how everything works. We don't do that. We've just given people more options, more capabilities as to what they can do with Salt states. Now, the first thing I want to mention is this new listen keyword. Now, in configuration management, there is an age-old battle between the philosophies of should everything be written in a declarative fashion or an imperative fashion. A declarative fashion says you declare how a system is supposed to be set up, and then the config management system ensures that it is set up that way. In a declarative fashion, you have to say that this service requires that this package is installed, or this service requires that this file has been laid down before we do anything with this service. Some people really like that approach, and that was the original approach that I wrote for the config management systems in Salt. But a lot of people like the imperative approach more because it just says, here's a list of steps that you take to get things done. And so this release, we've added the listen keyword, which allows you to create a fully imperative deployment of Salt states. So that now, if you're using the listen keyword and not using any requisites, which allows you to have those linking between different components, everything will just run in the order in which it is defined in the file. The other nice thing is that you can mix them. So one person who likes doing things in an imperative fashion can write their Salt formulas imperatively, and then somebody who likes to do it declaratively can write declarative ones, and they will run together in a seamless fashion. The declarative ones, or the imperative ones, will execute in the order they're defined in a completely predictable way as that person expects them to, and the declarative ones will execute in a completely declarative way. So it is able to satisfy both sides of that philosophical coin in a very succinct way. Okay? Now, how the listen keyword works to enable this is that salt states have executed in an imperative way for a long time, but when we add declarative features in, then they start to reorder themselves according to how you've said that, oh, this service requires these other things. But what the listen keyword does is that it allows us to say that if we listen to something, that just means that once we're done executing, tack another routine onto the bottom to run a little extra. So for instance, in Salt, you would say, I've got a file, I've got a package, and I've got a service that is watching the file and the package. If the file changes, then we use the watch requisite to say to the service, restart that service or reload that service because the file changed, which is one of the benefits of a declarative approach. But that changes the order in which things are executed. With listen, if you say listen and say restart this or reload this service when this file changes, then it won't change the order in which anything happens. It'll just tack that reload of the service at the end of the states. Okay? So everything stays in the same order. So again, it allows you to do what you want to do, what makes sense to you, instead of coming back and saying, please march to our philosophy. Okay. I should probably point out, I did make a bit of a hubbub about guy A can do this and gal B can do this. But as an organization, it's good to, kind of keep in step. Just because someone gives you some rope doesn't mean that you need to build a heaven knows what out of it.
Noose.
I'm trying to be politically correct up here. Okay. The next thing I want to talk about, which is really exciting, is this new feature called mod aggregate. One of the big problems we run into when we're running config management systems is that they are made to make atomic changes to the system. They're made to be able to say, change this file, install this package, install this package, install this package, start this service, start this service. They're not really good at batching things. The mod aggregate system allows you to dynamically batch executions. So it is now able to say, okay, while we're setting up this system, we need to install 40 packages. And normally that means we're going to call yum or apt-get 40 times, because you've got to call it for each package, which is slow. If you turn on mod aggregate, the first time it finds a package, it will scan everything else, everything else in your run, take all the package names, and install them all at once right at the top with a single call. This changes, for most runs, we're seeing an average of 40 to 60% performance increase from this. We're already executing 30 to 60% faster than anyone else in config management. And now we're faster. Okay, so mod aggregate is really slick. But how it works is that during that runtime, it kind of, I keep saying it works kind of like a JIT compiler, but that doesn't help anybody. During the runtime, when it's actually going through and executing your stages, it's able to modify the runtime, modify the data that it's working with dynamically, so that it can build these optimizations in. Okay? All right. We've got new stuff to make us more imperative. We've got new stuff to make us more declarative. We've got new requisites so that we can trigger changes in behavior during the execution if something fails or if something changes. So that you can branch out, so you can say, if this execution doesn't go, That's okay, try this one. Okay? If this changes something, then I should do this additional step before we get back into the main sequence. All right. Only if and unless are global now. People have wanted that for a while. For those of you who are familiar, that's cool. That means you can put a little only if stance on any state that's going to run, give it something to shell out to, and then determine if it's going to run based on that shell out. It used to only work on cmd.run, on literal shell outs. Only shell out if this shell out says to shell out, but now it works on anything. Okay. All right. Normally I'd stop and ask questions, but Rhett yelled at me not to. Okay. The next thing is that Salt's scheduler has been substantially improved. Originally, the Salt scheduler was made to say that after we start, we will wait so long and then do a task, and then wait so long and do a task. It was very simple. The scheduler in Salt now is fully cron enabled. You can set tasks to run remotely or locally on minions, or run them from the master, run them independently based on all of the syntax that you're used to working with in a cron file. So it's now ridiculously dynamic. Okay? Red Hat 7 is supported. Let's see, what do we got here? This is kind of the laundry that's left over. I'm trying to see where the exciting things are. Fileserver backends work in Salt call. We have had substantial enhancements to our Amazon support, so that in the past Salt Cloud worked primarily with Amazon Compute and Amazon Storage, but now it works with virtually all of the Amazon things. So you can automate the deployment of every aspect of an Amazon cloud from nothing with Salt now. Okay. We've also received a lot of updates for a few other clouds as well. And we've got the addition of a number of extra clouds, including Alibaba's new cloud. I can't read their homepage. Okay. The next thing that a lot of people are really excited about is containerization. Docker has been mentioned a lot lately. We have recently added a number of enhancements around our ability to manage and automate the deployment, maintenance, and virtually every other aspect of Docker. The idea here being that you can use Salt's remote execution and state system to ensure that you have Docker containers of a certain type and of certain numbers deployed. More importantly, we've added a number of data wrappers around Docker's networking systems. For those of you familiar with Docker, it really likes to do a lot of stuff with netting and port mapping. This version of Salt, every time you set up a Docker container, it makes available to your infrastructure an easy to parse data structure or easy to iterate data structure that tells you information about where all of your Docker containers are mapped, which means that you're able to do something like set up a ton of Docker containers, and then all of that information is in a single data structure on the Salt master, and have HA proxy or a load balancer. I shouldn't say HA proxy, just any old load balancer. And then use Salt to iterate over that data structure to dynamically set up the config. Now that means that every time you set up a machine, you can build those routes to that machine dynamically and automatically into virtually any networking overlay system that you have. Okay. Now the other thing that we put a lot of work into is LXC. I know that everyone's been screaming Docker and app containers, but we have had quite a few requests and quite a few companies that have come back and said that they don't want app containers, they want full stack containers. And that's why we put extra effort into our LXC systems. When you install Salt, you can now use the Salt LXC runner system to spin up and deploy LXC containers as if they were virtual machines. There is virtually no additional setup required to do it. All you've got to do is make sure that LXC is installed on the target system you want to spin up LXC containers on. You can run a command and it'll spin it up. We've got routines that will pull down existing container images and deploy them, but we also have routines that will dynamically create a container on the fly on the target system for you. So you can just say, hey, generate me an Ubuntu container, and assuming the host has access to the Debian toolset, which would be apt-get and to Bootstrap, it can deploy it. It actually doesn't, some of them don't need access. You can be running heaven knows what, like Arch Linux on the host, and say, give me a CentOS 6 machine, and it'll just make it. Okay? So we're very excited about our LXC additions. Some of these, we just haven't filled it out yet. There's lots of new OpenStack stuff. A lot. Okay. We've got, I'm really excited about this one. We have a brand new Chef execution module. It makes managing Chef with Salt just way easier. You'd be surprised how often this comes up. We've got one for Puppet too. We've had one for Puppet for years. The guys at Wikimedia wrote it. But yeah, I mean, we've got a number of users and even customers who come to us and say, we want Salt for cloud, we want Salt for code deployment, we want Salt for automation, and we want the reactor, we want all these things. But we're already using somebody else's config management system. Are you going to hate us? We say, oh no, we're good. We're more than happy to automate someone else's automation as well. Okay. I already talked a little bit about the file server backends. They've received considerable extra development. If any of you used the file server backends when they were first created and released in a beta stage, they don't suck anymore. Sorry about that. It's very, very, very smooth now. Okay. Yeah, and I think that covers the big pieces. Let's see. I'm just trying to think of any other quick comments I should make. We've got a lot of extra support for CoreOS and etcd. We've got, we support in many ways now Oracle databases. I can hear the crickets, that's wonderful. No, we've had some customers come back with that one. But usually in these sorts of meetings, nobody ever wants it.
It's because you said in many ways, and you said how we support them. They were just waiting to hear what other ways you don't.
I don't know how we don't support.
It's Oracle, we don't care anymore.
Okay. Yeah. That's a extremely terse overview of what's coming in the next release. Again, the vast majority of the development that we've done has been based around RAET and Salt SSH, and around all of these additions to the formulas, to the Salt state system. Now, does anybody have any questions?